Hello student, I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss nomenclature of organic compounds. Last class I have discussed three-dimensional representation of organic molecules and classification of organic molecules, and also I discussed homologous series. Now I am going to discuss nomenclature of organic compounds. This is very important, full of concept, hence listen carefully. Organic chemistry deals with millions of compounds. In order to clearly identify them, a systematic method of naming has been developed and is known as IUPAC, that is the International Union of Pure and Applied Chemistry. IUPAC system of nomenclature. IUPAC system of nomenclature. IUPAC means International Union of Pure and Applied Chemistry. In this system, the names are correlated with a structure such that the reader or listener can deduce the structure from the name. In this systematic nomenclature, the names are correlated with the structure such that the reader can deduce the structure from the name. Before the IUPAC system of nomenclature, however, organic compounds were assigned name based on their origin or certain properties. Before IUPAC, organic compounds were assigned names based on their origin or certain properties. For example, citric acid is named so because it is found in citrus fruits, and the acid found in red ant is named formic acid. Acid found in red ant, ANT, red ant, is named formic acid. Since the Latin word for ant is formica, that is the Latin word for ant. Ant is called formica in a Latin word. These names are traditional and are considered as trivial or common names. Some common names are followed every day. For example, Buckminster fullerens. Already I told previous class about the Buckminster fullerens. This is a common name given to the newly discovered C60 cluster. That is called Buckminster, not minister, Minster, M-I-N, not minister, Minster fullerens. Buckminster fullerens is a common name given to the newly discovered C60 cluster, a form of carbon. Noting the structure similarity to the geodesic domes popularized by the famous architect R. Buckminster Fuller. His name was R. Buckminster Fuller. He has made one structure, and that was geodesic domes. Then Fullerens structure was matching with these geodesic domes, and that was formed by architect R. Buckminster Fuller. Only by his name that compound C6 is known as fullerene. Common names are useful and in many cases indispensable, means compulsory, indispensable, particularly when the alternative systematic names are lengthy. If a systematic name is lengthy, then a common name is called. It is called by common name when systematic names are lengthy and complicated. Common names, I am telling you some these things, common names of some compounds. Now I am telling you, then you will understand. What I am now going to tell, that is the common name. As for example, first example is methane, CH4. Methane is common name for CH4. Now for normal butane is the common name. Then here you know that 4 carbon will be there. 4 carbon will be there. Means first and last will be the CH3. First and last will be the CH3. And in the middle 2 carbon, they are CH2, CH2. It means CH3, CH2, CH2, last CH3. This is called normal butane. Now isobutane. Isobutane means with the center 2 carbon will be attached, total 3. Then but I am telling about the isobutane, hence total carbon will be 4. It is a branch actually. Branch, methyl group will be in the branch. Then you can write as a CH3 whole 2. One CH3 in the beginning, other CH3 in the last, and one CH3 in the branch. Correct? That is attached with the central carbon. Central carbon means CH3 whole 2, CH3. Total 4. But one CH3 is in the form of branch. It is called isobutane. Iso means, if you can say 3 carbons are, 2 more carbons means 2 carbons are attached to the third one. Okay, then total 3. But here long chain is butane. 4 carbons are there. Then with the second CH3 is attached, and branch is also attached with second. Okay, then this is called isobutane. Like that way, neopentane. Now neo means here with the central atom 4 methyl group will be attached. 4 methyl. 3 means iso. 4 means neo. Okay, this is the important neo. That is neopentane. Neopentane means 4 is attached, then 1 is the center. The total 5. Like that way, 3 is attached with the center, then iso. 3 is attached, then iso. And 4 is attached with the center, then neopentane. Like that way, N-propyl alcohol. N-propyl alcohol means normal propyl alcohol. Small n. N means normal propyl alcohol. Propyl means, now we are understanding that OH group is attached. OH group is attached with propane was there. Then propane, 1 hydrogen gone. Then it became propyl. After losing 1 electron, it is called propyl, 3 carbon. And OH group is attached. And it is a straight line. That's why it is called normal propyl alcohol. Okay. Then it's a compound, you can write CH3. And this in the beginning and the end. Beginning is CH3 and end OH group is attached with CH2. Because CH3 was there actually. 1 H gone and its place OH has come. Then last became CH3OH, and in the middle CH2 is there. Then CH3, CH2, CH2OH. That is the normal propyl alcohol. Like that way, last class I told you formaldehyde, CHO. CHO group is aldehyde group. Hydrogen is attached. Then became formaldehyde. Then this is also common name. Like that, in normal propyl already told you, and formaldehyde also I told you. These are the common name. Acetone, then CO, COO in the center. Left side CH3, right side CH3. This is called acetone. That is the CH3 whole 2 CO you can write also. Left side CH3, right side CH3, in the middle C is there, that is attached with CO. Then CO and 2 CH3. Then you can write CH3 whole 2 CO. That is the acetone. Like that way, chloroform CHCl3. Methane gas is there, na CH4. Then out of 4H, 3H gone and 3Cl came in its place. Then now it became CHCl3. 4H was there in methane, 3 just displaced by chlorine atom. 3H gone, 3Cl came. Then only one hydrogen is remaining there. Then CHCl3, that is called chloroform. Now acetic acid, previous class also I told you that now in the place of H, CH3 came. Then acid is a COOH group. Carboxylic group is COOH. Then with this, if one H will come, then formic acid. If in the place of H, CH3 will come, then CH3 COOH. That is the acetic acid. HCOOH is formic acid, and CH3 COOH is called acetic acid. This is also common name. And benzene already I discussed. C6H6 is called benzene. Benzene is also common name. And anisole with benzene ring. If one hydrogen gone and its place OCH3 group has come attached, OCH3, then this is called anisole. And like that way, aniline. If you can say in benzene ring, if one hydrogen gone and its place NH2 joined, NH2, then this is called aniline. Means NH2 C6H5. NH2 group attached in benzene ring. One hydrogen gone and NH2 came. Then obviously NH2 C6H5. That is the aniline is also common name. And again you can tell acetophenone, just like acetone. Acetone you told that CO group in the middle and one side CH3, other side CH3. But now if in the place of CH3 benzene will come both side, means C6H5, in the middle CO and again C6H5. Left side, right side C6H5 is attached. Then that is called acetophenone. On means ketone, CO. Then C in the middle, CO. Left side C6H5 and right side C6H5. Then this is a acetophenone. This is also common name. And ethyl methyl ether. Then what is the ether? Ether is actually general formula is ROR. O is in the middle. Left side R, right side R. 2 R is attached with O. O is in the middle. This is called ether. If one R is C2H5 and other R is CH3, actually R is there now. One may be R, other may be R dash. Then suppose R is equal to C2H5 and R dash is equal to CH3. Means one side C2H5, other side CH3 is attached. In the middle oxygen is there. Then this is called ether. Ethyl, methyl, ether. Then this is also common name. Then I have told some common name of organic compounds. This is actually popular by this name only. Now come to the I am starting now the IUPAC system of nomenclature. It will take more time. Actually, this will take more time. Then whatever is possible in 1 hour class, I will discuss. Okay, rest I will discuss in the other class. The IUPAC system of nomenclature is very, very important. A systematic name of an organic compound is generally derived by identifying the parent hydrocarbon and the functional group or groups attached to it. Means first here all things are very conceptual. You have to not remember. Only important point you have to remember. Then here first you have to find out parent branch. Okay, parent hydrocarbon you have to, means long hydrocarbon you have to first find out which is a long hydrocarbon. Hydrocarbon means compound of carbon and hydrogen. Then just example, CH3, CH2, 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 CH3. Suppose between the CH3 and CH3, 5 are there. Then 5 plus 2, 7, long hydrocarbon. This is called parent hydrocarbon or chain, main chain. And in this chain or in this parent hydrocarbon, some group may be attached at any carbon between the CH3. Sometimes first carbon also it can attach. Then that time one H will go. Then only CH2 will be there and that group will be attached. Then CH2 as for example OH. Then in the beginning CH2 OH will be there, not the CH3. CH2OH. OH may be anywhere and the last also. Then again there will be CH2OH. Okay. Then this is alkyl group. Then OH group may be attached anywhere. Other group also may be attached. As for example, CHO group is there. Then CHO-aldehyde group also may be attached. Many groups I told you, methyl group, ethyl group, any group, NH2 group may be attached with this parent hydrocarbon. This is the very, very important point I have told you. Then here branch like CH3 can attach, functional group also can attach, means maybe bromide, chloride, iodide, OH, anything. Parent chain already told you, long hydrocarbon chain is called parent chain. Okay, this is only in the beginning I told you many things. Okay, major things now I have told you. Again you listen. By further using prefixes, there are two terms, prefixes, suffixes. Two terms are there, prefixes and suffixes. SUFFIXES, suffixes. SUFFIXES, suffixes, and prefixes, PREFIXES. Then what is the difference between two? means before it will come, before the name. Just name you are writing, then first will be this only. Okay, before the naming, what you will write first, that is the pre. Pre means before only. And suffix means it will come in the last. Last. Suppose you are talking about the chloroethyl alcohol. Chloroethyl alcohol. Then chloro is here, prefixes, and alcohol is in the last. You are taking name in the last, then that is the suffixes. Okay, that is the suffixes. Suffixes, SUFFIXES, suffixes. Then I think I now have understood. Chloroethyl alcohol. Then chloro is using first, that is the prefixes. And alcohol you are taking name in the end, that is the suffixes. That is actually in alcohol compound, chlorine is attached. Chlorine atom is, halogen is attached, maybe chlorine, bromine, iodine, anything. Then this I told you, by further using prefixes and suffixes, the parent name can be modified to obtain the actual name. Compounds containing carbon and hydrogen only are called hydrocarbons. Already I have told you. A hydrocarbon is termed saturated if it contains only carbon-carbon single bond. Then it is a saturated. If double or triple bond, then it is called unsaturated. The IUPAC name for a homologous series of such compound is alkane. For saturated compound, that is called alkane, saturated first compound. Okay, alkane. Then what is its meaning? Alkane is also called paraffin. Paraffin means little affinity. Latin word is little affinity. Parent. A paraffin means little affinity. It is a Latin word. And then here I have told you that IUPAC name for a homologous series. Homologous series, it differs by CH2. Okay, CH2. And then for a homologous series of such compound is alkane. The IUPAC name for a homologous series of such compound is alkane. Paraffin was the earlier name given to these compounds. Alkane was also called paraffin. Paraffin means little affinity. Unsaturated hydrocarbons are those which contain at least one carbon-carbon double or triple bond. That is the unsaturated. Now I am going to tell IUPAC nomenclature of alkane. Just now I am starting with alkane. Many are there. Alkane is there, alkene is there, alkyne is there, benzene is there. Many compounds are there. Then I will discuss one by one to all. Okay, all things in details I will discuss. These are very, very important, and in all examination, competitive examination, these questions are asked from nomenclature, IUPAC. Then a straight chain hydrocarbon. I am talking about a straight chain hydrocarbon. Alkane actually I am talking about. The names of such compounds are based on their chain structure and end with suffix ane and carry a prefix indicating the number of carbon atoms present in the chain, except for methane. Methane methane to butane, there will be no prefixes. They will be called methane, ethane. First carbon, only one carbon is there, then methane. If two carbon is there, then ethane. Three carbon is there, then propane. Four carbon is there, then butane. But everywhere ANE will be there. No prefixes, only suffixes. ANE, alkane, ANE. Then methane, AN is there. Ethane, AN is there. Propane, AN is there. Butane, AN is there. Butane means 4. Then this is the suffixes ANE. But prefixes, now I am telling you. Then here up to 4 you have to not write the prefixes, where the prefixes not derived from trivial names. The IUPAC name of some straight chain saturated hydrocarbons I will tell you. Okay, then you will understand prefixes and suffixes. The alkanes differ from each other by merely the number of CH2 groups in the chain. Already I told you, all homologous series differ by CH2 only. CH2 difference will be there. They are homologous of alkane series. This will apply for every series, with every series. But here first you apply for alkane. Alkane, all alkane, already CN, H2N plus 2. This is the formula for alkane, CN, small n. That is the number of carbon, CN, H2N plus 2. This formula is asked in examination. Then now N will differ. If N is equal to 1, then now you can write easily alkane. You can write what is the formula. Cn is equal to 1, then CH4. Because N is 1, then CnH2n plus 2. Then C H2n, 2n means 2 plus 2, 4. Then CH4. Next again, if N is equal to 2, then now it becomes C2. There 2 hydrogen will increase. Like that way, if C is equal to 3, then C3, there 3 into 2 plus 2, 8. Then like that way, every time for one carbon, 2 hydrogen will increase. Okay. Then I am telling the some examples. Then methane is CH4. Methane is CH4. This is the homologous series I am talking about. Ethane is C2H6. What are the difference? Then only CH2 difference is there. CH4, 1 carbon, 4 hydrogen. Now 2 carbon, 6 hydrogen. Then differences of CH2. Now propane. Now 3 carbon is there. 3 carbon is there. Then 1 carbon increased and now H8. Then ethane 6 hydrogen was there. Now 8 hydrogen. Then CH2. Butane also C4H10. CH2 difference. Pentane again. Pentane C5H12. Here also there is a difference of CH2. Hexane. Hexane means 6. Pentane means 5. Then here you can see 6. C6H12. Okay. Then now you can see pen. You have used the word pen. Pentane for the pentane. Pent. P-E-N-T. Pent. This is the prefix. This is the prefix. Pent. After that hexane. H-E-X. Again it is the prefix. Hexane. Means 6. Then C6H14. Now like that way hept. H-E-F-T. Hept. A-N-E. Hept. Again it is the prefix. Like that way heptane means C7H14. In formula you put CnH2n plus 2. You will get all these things. Homologous series. Octane means 8. Then oct, O-C-T, oct is the prefix. No, then A-N-O-N, non, nonen, nonen. Then N-O-N, non means 9. Then C9H20. Okay, these are actually homologous formula. You can tell that is actually series you are telling, but formula, it is formula, molecular formula for Deccan. Like that way, Iicos means 10. Iicos means 10. Iicos N means not Iicos. This is the 20. Dec means 10. Dec means 10. Nonen means 9. Nonen means 9. Dec means 10. And Iicos means 20. Then 20 plus H14. C20H42. C20H42. Obviously 2n plus 2. Then C is 20. 20 into 2, 40 plus 2. 42. Like that way, triaconten. Triaconten means 30. Tri means 30. Triaconten. That is the C30 H40 H62. C30 H62. 62. This I have told you nomenclature of alkane. Okay, alkane. Now, alkane may be in the branch for straight also, may be branched also. May be straight, may be branched. Then what I told you now is straight. Methane, ethane, butane, all are the straight. Now, I am going to tell about the alkane. This is also alkane, but branched. Branched chain hydrocarbons. Branched chain hydrocarbons. In a branched chain compound, a small chains of carbon atoms are attached at one or more carbon atoms of the parent chain. The small carbon chains are called alkyl group. The small carbon chain, that is also called branches, which will be attached with the parent main. Then the small carbon chains, also called branches, are called alkyl groups. Alkyl groups may be methyl, may be ethyl, may be propyl. For example, suppose butane is there, CH3, CH2, CH2, CH3, total 4 carbon. Now suppose with second one hydrogen gone and one methyl group attached, then this is the branched. This is the methyl butane. This is the methyl butane. Okay. Like that way, other group may be also there. 2 groups may be attached. Suppose with second and with fourth. Suppose now it is a pentane. Now suppose it is a pentane. In the beginning CH3 and the end CH3. In the middle CH2 is there. Then now suppose second and fourth 2 groups are attached. One is CH3 and other is CH2 CH3, ethyl group. One is methyl group attached, other is ethyl group attached. Ethyl group is CH2 CH3, or you can write C2H5 also. C2H5 in elaborated form CH2 CH3. If you add all, it will become C2H5. Then these group people, if these groups are attached, methyl group and ethyl group both are attached with pentane, then this is also a branched chain hydrocarbon. Only carbon hydrogen will be there, no other. In order to name such compounds, how will you name of this? This is the branched, I told you. How will you name? In order to name such compounds, the names of alkyl groups are prefixed. Means first you write the alkyl group which is attached and then parent's name. The names of alkyl group are prefixed to the name of parent alkane. An alkyl group is derived from a saturated hydrocarbon by removing a hydrogen atom from the carbon. Correct? That already told you. If from the methane, if you remove one hydrogen, this is the methyl. If from the ethane one hydrogen removed, then it is called ethyl. If from the propane one hydrogen is not there, then propyl. Like that way, butyl, pentyl, hexyl, heptyl, octyl, nonyl, like that way. Decyl. Then one hydrogen is removed means one electron will be there. Then if one electron is there, then they will can make this type of group may make a bond with the parents hydrocarbon. Always one hydrogen is not there. It means what? One electron is there. That group will be very, very reactive, and they will be always ready to make the bond at a proper place. Then this I have told you about the alkyl. These all are called alkyl group in general. Methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl. These are the called in general alkyl group, and it is represented by R. It is represented by R, capital R. Then this I have told you. An alkyl group is named by substituting YL. YL already ANE was there, na? Alkane ANE. But YL, alkyl, methyl, YL is there, methyl, ethyl, YL is there, propyl, YL is there, butyl, YL is there. Then this alkyl group is carried by substituent YL for 1. For ANE you have removed. Alkane was there, ALKNE. Then ANE you have removed and YL you have added. Alkyl. Alkane, AN you removed and YL you have added. Then like that way, methane. Methane was there, AN you removed, YL you have added. Methyl, like that way with all. Then now again I am telling you that already I told you methane ANE is removed, and now after CH from the CH4 one is gone, then it becomes CH3 and 1 dash. CH3 1 dash. Dash means here one electron is there, one orbital is there. Okay, that can make the bond. Then CH4 becomes CH3. It is called methyl, means methane became methyl. C2H6 ethane. Ethane became CH2CH3. One hydrogen gone. Then ethane became ethyl. Propane became propyl. Butane became butyl. And decane became decyl. Okay. Abbreviations are used for some alkyl groups. Now see, many rule regulations are there. Slowly and slowly you will understand. And by practice is must. Without practice, nomenclature you can't write. Sometimes this structure will be given, and then you have to write the IUPAC name. And sometimes IUPAC name they will give, and they will ask to write the structural formula. Hence, many rule regulations they are there. Then slowly and slowly you try to understand. Abbreviations are used for some alkyl groups. For example, methyl is abbreviated as a ME, capital M, small e, ME, methyl, 2 letter, capital M, small e, methyl. For ethyl, ET, 2 letter is used, ethyl, ET. Just like methyl, 2 letter you have used Me. Like that where ethyl, Et, capital E, small t. Propyl, again 2 letter Pr, capital P, small r. One is capital, other is small. Propyl. Butyl, Bu, capital B, small u. Correct? These are the abbreviation. The alkyl group can be branched also. The alkyl groups can be branched also. Thus, propyl and butyl groups can have branched structure. Means I am telling you now this isopropyl, already I have told you. Isopropyl means 2 carbons are attached with third. Okay, total 3. Then because 3 carbons are there, then third carbon is in the form of branch. Ethyl group CH3, CH2 is there. Ethyl group. In ethyl also branch may be there. Like CH3. CH2 is there. Then CH2 you can write CH and 1 dash. But from this carbon, CH dash, another group may be attached, like methyl. Then now total became 3 carbon. 2 is a straight, 1 is branch. Methyl is attached. Then now this is called propyl. Isopropyl. This is called isopropyl. Propyl is due to 3 carbon. It is a branch. 2 carbon is straight, 1 is down. Then it is called propyl. Okay. And 1 dash you told you have left. No, they don't know there what group will be there. If it is alcohol group, then you can tell propyl alcohol, like that way. Now second example I am telling you. Now with propane, CH3, CH2, again CH2 is there. But you can't tell why CHH you can write, CHH dash, because again you don't know with this compound what group is attached. That's why you are leaving 1 dash at the end. Complete you should not write, because you don't know which group will come. Okay, maybe alcoholic group, maybe NH2 group, maybe bromide, iodide, anything, you don't know. Hence, last just 1 dash write only. Dash means 1 electron is there. It can make bond with others. Then now with this propane or propyl, you can tell again 1 group may attached. Already only 3 carbon, this branch is there. But in that also methyl group may attach as a branch. Okay, then it will be called secondary butyl. Actually, I am telling you meaning of primary, secondary and tertiary. Don't confuse. If with the central carbon only 1 carbon is attached, then it is called primary carbon. Primary. With the central carbon atom, if only 1 carbon is attached, only 1 carbon, then it is called, including center, it is a 2, but only 1 is attached with the center, then it is called primary. If 2 are attached with the center, then it is called secondary. If 3 are attached, then tertiary. If 4th are attached, then quaternary. This is the prime meaning of primary, secondary, tertiary, quaternary. Okay. Then generally primary, secondary, tertiary, quaternary is also there, but rare. This primary, secondary, tertiary compounds are common. Then here you can see CH3, CH2, CH. With that last carbon CH, one methyl group is attached. Then now you can see it is called secondary butyl. Why? Because with that carbon, last CH, two carbon is attached. One is a straight carbon, what was coming that, and branch. Two carbons are attached with center. Okay, then this is center or any carbon, two are attached, then it is called secondary. And total, including branch, how many total carbons are there? Then 1, 2, 3, 4 carbons are there. Then 4 means butane. That's why it is called secondary butyl. Secondary butyl, because one hydrogen you have dash, you have written dash. Then finally 4 carbon is there, then butyl, because one dash is there. Butyl. Like that way, I am telling you another example, isobutyl. Then same things, but if CH3 group is attached with the middle carbon, then middle carbon means you can use the word iso. Middle carbon, if methyl group, that time I told you last time, it was attached with the last, then simply told butyl was there, secondary butyl. But now here 3 carbons are this with the central, 3 carbons are attached. Left side CH3, right side CH3, one down CH3, and one H is attached. Then if 3 carbons are attached, then that you told you, this is the called tertiary. But here also you can tell iso. Then total number of carbon is 4. 3 plus 1 CH3 is down. Then it is the isobutyl. Okay. Now I am giving example of tertiary butyl. Only same compound isobutyl, I told you isobutyl. Then here covalency was full. Carbon has 4 valency everywhere. What I told now in case of isobutyl, every carbon has 4 valency. Center already, left is 1 carbon, right is 1 carbon, down is 1 carbon, and fourth one is attached with hydrogen, 4 valency. And each carbon is also has 4 valence. CH3 means 3 valence is over, 3H is there, and fourth one is with carbon, attached with the neighboring carbon. Then all are carbon is valency is satisfied. 4 valency is satisfied. But now here I am telling you tertiary butyl. All things are same, isobutyl, but hydrogen they have removed. Hydrogen in the one hydrogen was there, they have removed. Then it became butyl, YL, it became tertiary because 3 carbon is attached. Then now it is called 3 carbon is attached with the center, total 4. That's why it is called tertiary butyl. 3 carbon is attached, then that is a tertiary, but total including center, that is the 4. That's why it is called tertiary butyl. But H is attached, then it will called isobutyl. If H is there, middle 4 valence is over, then it is isobutyl. But one hydrogen is not there, then it is called tertiary butyl. And neopentyl is very, very easy. Every side carbon has 4 valency, all 4 valency is attached with methyl group. Left CH3, right CH3, up CH3, down CH3. Means 4 valency, carbon has 4 bond, all are attached with methyl group, CH3. Left side CH3, right side CH3, up side CH3, and down CH3. Means with center 4 methyl group is attached. Then this is called neopentyl, because total 5 are there. 5 methyl plus 1 carbon, total 5. That is called neopentyl. But here pentyl, because you are writing pentyl, YL, then obviously one hydrogen is not there. Then any one you write CH2. Everywhere CH3 was there. That is a neopentane, A and E. But here you are writing neopentyl, means one hydrogen is removed. Then now 3 CH3 will be there and 4 CH3 will become CH2, 1 dash. Okay. Then this is the neopentyl. Now I am telling you further. That is the common branched groups. Common branched groups have a specific trivial names. Common branched groups have a specific trivial names. For example, the propyl groups can either be N-propyl group or isopropyl, but it will be propyl only. Okay, common branched group have a specific trivial name, old name. For example, propyl groups can either be normal propyl group or isopropyl group. The branched butyl group are called secondary butyl or isobutyl and tertiary butyl group. Three names are there. The branched butyl groups are called first secondary butyl, second isobutyl, third tertiary butyl group. We also encounter the structural unit. As for example, I am telling you, a structural unit means CH3, Cl, CH3 whole 3. See here, CH3, and with this CH3, one chlorine atom is attached. CH3 you write 1 dash only in the beginning. CH2 1 dash, and carbon is 4 valence, the 1 is dash. Then 2 hydrogen attached and 1 chlorine is attached. Then now it became 3. 1 is a dash. 1 is not Cl. C you consider carbon, only carbon atom. With the central carbon, 1 CH2, 1 dash is there in the beginning only. Okay. With central, how you can tell, in the with second carbon, 1 CH2 is attached, and this carbon now have 3 more valency. Then everywhere CH3 is there. Then this is called neopentyl group. Already told you, pentane. Central 1 carbon is there and 4 methyl group is there. But in pentyl group, 1 hydrogen will go from the CH3. Then it will be called isopentyl group, and this is actually called a structural unit. Then now I have discussed this IUPAC nomenclature of alkane. Okay. Now next class I will discuss nomenclature of branched chain alkanes, because here many rules are there. 6 rules are there. Then it will take time. Then next class I will discuss this branched. nomenclature of branch chain alkane. This is also alkane, but branch chain. Many rules are there, 6 rules are there. Then next class I will discuss. Thank you.